Hi there. Here's your video for section 2.2, which is all about these things called conditional statements. So the goals to have written down, we actually have two goals for this section, and they can both go in your goal sheet. The first is to recognize conditional statements and their parts. The second one is to be able to, so that's number one. The second one here is to be able to write converses, inverses, and contrapositives of conditionals. So those are not terms that you're probably familiar with yet, but you will be soon. All right, so take a moment if you need to pause it to write those down. As you do, I like the picture that's in the background there. I saw this, I don't know where I saw this, but that just scared the bejeebers out of me. Those are tents hanging on a cliff, and people just sleeping in those tents that are hanging from the side of the cliff. So I thought that was pretty ridiculous. But anyway, here's kind of our warm-up to this section. It says the company that prints the bumper stickers at the left, well, actually the bumper stickers are on the right, accidentally reworded the original statement and printed the sticker 3 different ways. Suppose the original bumper sticker is true. So the one that, I guess that's the one that's on the left. Are the other bumper stickers true or false then? So if you look at these, and I don't have the opening questions on here right now, but so look at are they all true statements based off of that left one? And how are they similar, how are they different is kind of what I'm asking. So the original says, if you can read this, then you are too close. The second one here says, or A, says, if you are too close, then you can read this. Is that always true? I don't know. Second one says, if you cannot read this, then you are not too close. Interesting. And the last one says, if you are not too close, then you cannot read this. So they're all kind of spin-off, they're all if-then statements, and that's what conditionals are that we're going to talk about today. But they're all using the same verbiage, just kind of either switching things around or changing it to not. So that's kind of what we're talking about today. I'm not going to go into any further detail about this right now, but I want you to learn about what these statements are. So, with that, let's start. So the study of if-then statements, that's what these things are. And their truth values is a foundation of reasoning. We're talking about reasoning this whole chapter, finding different kinds of reasoning. So if-then statements join two statements based on a condition. So the condition is the if part. Therefore, an if-then statement is called a conditional. That's called a conditional statement. Oops. Technically a conditional statement. I'm going to leave it at conditional. Every conditional statement has two parts. That would be a hypothesis. That would be the if part. And a conclusion. That would be the then part. So a hypothesis is the part following the P. So that is, I'm going to move this, and a conclusion comes, and this is stuff you've learned before, but the hypothesis would be the P. So right there. If P, then Q. Also right there. The conclusion then would be always the part at the end or after the then. I'll do one more arrow there. So if you see this box here, this P arrow Q, it's read if P then Q, or it's also read P implies Q. So that's where the hypothesis and conclusion comes in here. So if-then statements are called conditionals. So let's talk a little bit about these if-then statements. Here's an example. It says, if today is Wednesday, then you will have a quiz in geometry, which actually won't entirely be true. But if you look at this, what is the hypothesis and what is the conclusion? Well, the hypothesis we said is always the part before. So today is Wednesday, is the hypothesis. and then you'll have a quiz, or you'll have a quiz in geometry is the conclusion. Now, the if-then part is not part of the hypothesis or conclusion. That's what makes it a conditional statement. The hypothesis and conclusion is everything after the if and everything after the then. All right? So, shorthand if P then Q is what I had before. You already have that down, hopefully. If P then Q. Now, I'm going to have a couple examples here. So it says, write the following statements in if-then form, then identify the hypothesis and conclusion for each statement or conditional statement. So you're going to be given some things, you're going to have to write them in if-then statements. So it says, Robert Oppenheimer spoke 8 languages. So I could say this as, if you are Robert Oppenheimer, then you can speak 8 languages. Or if you want to keep it in the past tense, that's okay too. I'm going to actually try to make this smaller here, if I can get a hold of this corner. Apparently not. Come on here. Alright, so I got it now. So if you are Robert Oppenheimer, then you can speak 8 languages. So that's what makes sense there to me. Now, for this, I'm going to say green is the, or we'll say green is the hypothesis, purple is the conclusion. So green would be the part after the if. So you are Robert Oppenheimer. That would be this first part that I've pulled out of there. And then you can speak 8 languages would be your conclusion. Okay, let's try the second one. Purple and yellow are complementary colors. You could look at this a couple different ways, I guess. It just depends on how you write it. Okay, as long as the if-then statement makes sense. So, if you have purple and yellow, then you have complementary colors. Okay, and again, it just depends how you write it as to, because you could write that a different way as well. It could say like, if you are purple and yellow, then you are complementary colors. Or if purple and yellow are the colors of choice, then they are. It just depends how you write it, as long as it makes sense to the original statement. So we're not going to go into too much detail with that. But the way I have written it, the hypothesis would be that you have purple and yellow. Then the conclusion would be that you have complementary colors. All right? So that's basic conditional statements. Now, let's go into truth values and negations of conditional statements. So the truth value of a conditional is either, well, true or false. So statements can either be true or false. To show that a conditional is true, you have to show that every time the hypothesis is true, then the conclusion is also true. So if every time the hypothesis is true, the conclusion is also true, then you have a true statement. What would help determine whether a conditional statement is a true hypothesis, or a conditional with a true hypothesis is true? Well, let's look around here. So what you need to do to determine if it is a false statement, I guess, would be to look for a counterexample. All right. So if you find a counterexample, anytime you found one single counterexample, then that proves that your statement is not true. So let's just look at a couple here. If an animal has wings, then it is a bird. If an animal has wings, it is a bird. If you think it's false, then you have to give a counterexample. Now it depends what animals are. I'm going to say false though, and I'm going to say like a fly or a bee. That's my counterexample. I would still consider insects animals, and flies are definitely not birds. So that would be my explanation there. So number 2, if it is after sunset, you can see the stars. Well, I think that's definitely false. What happens if it is cloudy? There's my counterexample. Okay, so not always true. So let's talk about these things that are similar to counterexamples, but this is called a negation. The negation, so if you're negating a statement, the negation of a statement P is the opposite. So that's called, the symbol is called, or is like this little wavy thing that you put in front of it, little wavy symbol. That is pronounced not P. So anytime you see that wavy symbol when we're dealing with if-then statements, it is considered the word not. Okay? So what would be the negation of the statement, the sky is blue? Well, you could say, the sky is not blue. There you go. We're not saying the sky is green or white or anything. We're just saying the sky is not blue. That is called a negation. Okay, you'll see negations when we're dealing with conditional statements. All right, so let's, well, we're going to skip that for now. So now we're getting to the second part of our goal. The second one we had was be able to write converses, inverses, and contrapositives of conditionals. We just talked about conditional statements and their parts, negations and truth statements about those, truth values. But now we're going to talk about these things called converses, inverses, and contrapositives. They all stem from basic conditional statements. So, first of all, a conditional. The symbols for conditional we showed you was P arrow Q, and that's read if P then Q, typically, or P implies Q. So my example there is, if the sky is blue, then it is daytime. Sky is blue, then it is daytime. I don't know if this is in your notes, this little chart, but I would say if it's not in your notes, you should write it in your notes somewhere. Find a space for this, because now we're going to talk about this, the first offshoot of a conditional statement, which is called the converse. Converse, you'll notice it's P arrow Q, or Q arrow P, so that it's just backwards. So it's a statement that's, you're taking a conditional and you're just turning it around. You're saying if P, then Q. So we're going to go off of this first example and say the P part was here, the Q part was here. Now it's if it is daytime, then the sky is blue. All right? Now, that might not always be true. So if the sky is blue, then it is daytime. I think that's typically true. But if it is daytime, the sky isn't always blue, so you could maybe find a counterexample for that. But that's just a different way to write conditional. So that's called the converse. It's going to be hard to keep the converse and the inverse separate. But the inverse is having some negations in it. The inverse of a statement is saying if not P, then not Q. So let's say if the sky is not blue, then it is not daytime. If the sky is not blue, then it is not daytime. And let's say if the sky is not blue and if it's white, could still be daytime. So that's not always a true statement either. But that's how you write the inverse of a conditional statement. And the last one, you might be able to guess what it is. It's the contrapositive. It's going to be the negation and the flipped version of it. So converse was just flipping it. Inverse was just doing the negation of both sides. Now contrapositive is if not Q, then not P. So you're doing the negation of both sides and you're flipping the P and the Q. So an example would be if it is not daytime, then the sky is not blue. It is not daytime. The sky is not blue. That could be proven true as well. So Those are the different types of conditional statements. Okay? The 4 different types. We're going to do plenty of examples with those. But you need to know the difference between conditional, converse, inverse, and contrapositive. All right? Now our last major term for this section is called equivalent statements. We're going to be dealing with equivalent statements quite a bit. So equivalent statements here are 2 statements that have the same truth value. So if you have 2 statements that are both true, and we're talking about when we're talking about these 4 different types. So if the conditional and the inverse are both true, if we know they're both always prove true, then those are equivalent statements. If the conditional and the contrapositive are both true, then we have equivalent statements. Maybe just the converse and inverse are both true, then we have equivalent statements there. So 2 statements, and those statements have to be the conditional, the converse, the inverse, or the contrapositive. Wow. All right, so those are the 4 different types of statements that we're dealing with. And if we're talking about equivalent statements, it has to be 2 of those or more, I guess. That would be equivalent or both have the same truth value. They could both be false as well. So now we're going to go on to just showing one example here before we're done here. So it says, write the following statement as an if-then statement. Then write the converse, inverse, and contrapositive, and include the truth values. So we're going to put it all together. Our one statement that we have here is all rectangles are quadrilaterals. So we could say here for a conditional statement, putting that into an if-then statement, we could say if the shape is a rectangle, I'll make this smaller, is a rectangle, then it is a quadrilateral. See if that'll fit in there now. If the shape is a rectangle, then it is a quadrilateral. And I would say that is definitely a true statement. Every rectangle is a quadrilateral. Okay? The converse, let's look back. The converse is just flipping them. So going if Q, then P. So say if the shape is a quadrilateral, then it is a rectangle. Okay? Now that's how you write the converse, but I can tell already that's not going to always be true. If the shape is a quadrilateral, well, what about a square? Well, that's a rectangle. Shoot. What about a parallelogram? A parallelogram or a trapezoid? 4 shaped figures that are not rectangles. So all you need is one counterexample for it to be false. So far, those are not equivalent statements. All right, the inverse is just negating both the sides of the conditional. So if not P, then not Q. So we'll say if the shape is not a rectangle, then it is not a quadrilateral. Right, so we just negated both sides of the conditional. Let's think, is that always true? If the shape is not a rectangle, let's say it's a parallelogram, then it's not a quadrilateral. Not true. Parallelogram is a quadrilateral. So we have 2 equivalent statements there. The converse and the inverse would technically be equivalent. Now let's do the contrapositive. So we're flipping it and we are negating both sides. If the shape is not a quadrilateral, then it is not a rectangle. So let's think, if it's not a quadrilateral, like a triangle, it's not a quadrilateral, then it's definitely not a rectangle. Okay? Well, I can't think of an example. Let's see. Not a quadrilateral. What about a pentagon? It's not a rectangle. Hexagon, not a rectangle. I can't think of any counterexamples, so that is going to be a true statement. So that would be equivalent to the conditional. So that's how I wrote them. That's how you would change them into an if-then statement and find the converse, inverse, and contrapositive of each. I would like, it's up to you. I don't know how you can find a way to remember the converse versus the inverse. Those are the hardest two to remember the difference between. But if you find a good way to remember them, I definitely think you should share it with the class. So what you can do is you can finish up the notes with the error analysis there, and be ready in class to do some work with this and to be able to explain yourself when I asked you things about recognizing conditional statements and their parts and writing converses, inverses, and contrapositives of conditionals. I know it was a lot in one short video here and a lot of new stuff. I'll try to take it all in, and we'll do some practice with it the next day. All right, we'll see you next time.